Faraday's laws of electromagnetic induction. There are two laws of electromagnetic induction given by Faraday, and these laws are derived from the two experiments. So let us study the electromagnetic induction, the Faraday's laws, okay, and the experiment. So first what he did was, he took the coil, okay, a circular coil, and the two ends, example A and B are the two ends of this coil, okay. He connect it with the galvanometer in this fashion. In the next step, he brought a bar magnet close to this coil, and he started moving this bar magnet back and forth like this. Understood? And most important thing is that the magnetic field lines has to pass through this coil. Understood? So this is very important point. So the magnetic field lines has to pass through the coil. So he started moving this back and forth, and he observed the deflection of needle in galvanometer. So first observation was deflection of galvanometer needle. That was first observation. Now what is galvanometer? Galvanometer is device to detect the current. Now if there is deflection in the needle or pointer, please check the spelling, then what we say is, we say that there is flow of current. Now where this current came from? It has to come from a cell, it has to come from a battery, but is there any cell? No. Is there any battery? There is no cells and no batteries. Then where this current came from? We have to see this one. To see where this current comes from, let us give one example. Here we consider two tanks, this tank and that tank, with the same level of water, and these two tanks are also in the same line, that is, they are at the same level, okay. They are not like this, they are like this, exactly same level. And if I connect a pipe between these two, then what would we see? We would see that there will be no flow of water from this tank to that tank, because there is same level. That is the potential difference, okay. The potential difference is same. What is there? Their potential difference between this tank and that tank is same, therefore there is no flow of current. Now in the second case, let us block this and join it here, okay. Let us join this here with the another tank which is little more down than this one. So what will happen then? As we can see that there will be flow of water, and we know why there is flow of water, because this is at low potential and this is at high potential. Now if there is one tank is high potential, the another tank is at low potential, then there is potential difference. So there is potential difference, okay. Same here, potential difference is not same, therefore the water will flow. As compared to this one, similar to this one, let us see here why there is deflection. We say that there is deflection because some current has flown through it. Now we have considered the 2 points A and B, which are the two ends of this coil. Now if there is flow of current, like here there is flow of water, because there is potential difference between this tank and this tank, right? Similarly, what should be here so that there is flow of current? Here must be some potential difference between A and B, therefore there is flow of current, okay. So there is, what is there? Then there is potential difference, okay. This potential difference we can also call this as EMF, right? EMF. We have studied this in chapter 3. What is EMF? EMF and potential difference are same, both are voltage. So what we can say is that whenever we move this, whenever we change the position of bar magnet, there is the generation of potential difference, or there is generation of EMF between the two ends of the coil, and hence there is flow of current. Okay, so without doing anything, without touching this coil, what we are getting is, we are getting the current. So this phenomenon is known as electromagnetic induction. Electricity is generated due to the magnetic field. So the definition of electromagnetic induction is that the phenomena of generating or producing EMF and hence the current. Okay, first we generate EMF, and because of that EMF the current is produced. Okay, the phenomena of producing EMF and hence the current in the coil due to changing magnetic flux link with the coil is called electromagnetic induction, right? So here I introduce one word, that is flux, and another word is linked, L-I-N-K-E-T. So these two words are very important. So whenever there is magnetic field lines which is changing, isn't it? Whenever I move it here, the magnetic field lines, this will come here and there will be less magnetic field, and whenever I move it here, there will be more magnetic field lines passing through the coil, that is, there is change in magnetic field. Now if there is change in magnetic field lines, then there is change in magnetic flux, isn't it? Example, if this is my plane, consider the plane of this coil, and these are the magnetic field lines which is going through this, then these many magnetic field lines can be called as flux. Okay, so this is the flux, and this flux is linked, L-I-N-K-E-D, linked with the coil, isn't it? So again I will tell you the definition: the production of EMF and hence the current due to changing magnetic flux link with the coil is called electromagnetic induction. Okay, this magnetic flux is linked with the coil, so that is electromagnetic induction. Next thing is that number 2, let us not move this. Let us make it static. Static means it is not moving. Whenever we do not move this, okay, what we get is stop moving bar magnet. It was moving like this and deflection was there. Now let us not move this, let us fix it. Then no deflection in the galvanometer. So whenever we stop moving the bar magnet, there will be no deflection in galvanometer. What does this mean? This means there is no EMF and no current. If there is no EMF, then there is no current. So that is the another point. Now from these 2 points, the Faraday gave the first law. The first law says that the EMF produced in the coil, okay, the EMF produced in the coil lasts as long as there is changing magnetic flux. जो EMF और करंट यहाँ पर प्रोड्यूस हो रहा है वो तब तक ही एग्जिस्ट होगा, वो तब तक जिंदा रहेगी जब तक हम इस मैग्नेटिक फ्लक्स को चेंज करते रहेंगे. समझ गए बेटा? So whenever we stop this, there is no change in the magnetic field and hence there is no change in the magnetic flux. Therefore there is no EMF and no current. Okay, so again I will repeat, the EMF produced in the coil will last as long as the magnetic flux changes. Okay, once it stops changing, then there will be no production of EMF and the current. So now let us go to some hot topic. Okay, now the point is, if we move it more rapidly, then what will happen? Whenever we move it more rapidly, then there will be more EMF and hence more current. So how do we make more current? How do we make more EMF? By moving this bar magnet very rapidly, we may get the more EMF. Okay. So and next is that if we move both the things, that is coil as well as the bar magnet, whenever we move it like this back and forth simultaneously, that time also we get more EMF and more current. That is another way. Okay, we did first law, and from there we go, now we are going to second law. So in the second law he says that the EMF produced in this coil is directly proportional, or we can say that the EMF produced in this coil is equal to the rate of change of magnetic flux. Okay, so EMF, okay, this EMF, I will write it here, the EMF produced, in the coil is equal to the rate of change of magnetic flux. The rate of change of means ddt, flux is phi. So this is the second law of Faraday, electromagnetic induction. So it says that the magnitude of EMF produced in the coil is equal to the rate of change of magnetic flux. Okay, now it is sometimes also written like this. This epsilon is equal to minus of n d phi by dt, which is very important now. You must have understood why is this n here. This n is the number of turns. Okay, it means that if we change the number of turns, if we increase the number of turns, EMF will increase. Now what about this negative sign? This negative sign has come from Lenz's law, which is our next topic. So we can also write here Lenz's law, right? Which is my next topic. So we did first law, we did second law. Now let us go to the next experiment done by the Faraday. We have done this in 1831. In the second case, what he did was, instead of taking one bar magnet and one coil, he took the two coils. So let us say this is my primary and this is my secondary coil. Okay, and in the primary coil he connects it with this battery. This is positive and this is negative, and here he left it as it is, as this one, connected with a galvanometer. Now this is my DC current. Please remember, some people do not understand this. So this is my DC current. DC means direct current, that is current do not change. If it is 2 ampere, it will remain 2 ampere for very long time or forever. So this is my DC current. Now what he did is, let me write this is primary. Okay, प्राइमरी में क्या हो रहा है और सेकेंडरी में क्या हो रहा है, ठीक है. फर्स्ट केस, नाउ लेट अस put the key here. Let us put the key here. That is, primary key is closed. Okay, key is closed means it is on now. Okay, light is on. Now here in secondary, what we get is, we get deflection in pointer of galvanometer. Very important. Okay, whenever I insert the key, then what will happen? The current will start flowing here. That means whenever there is flow of current in the coil, there is production of magnetic field in this fashion. Okay, like this. Okay. So this is the magnetic field which is produced here, and this we can call as a magnetic flux passing through this coil like this one, isn't it? Now, why there is deflection in the pointer of the galvanometer? Because the magnetic field has produced here, and because of that magnetic flux there is generation of EMF, therefore there is deflection in the galvanometer connected with the secondary coil. Okay. So one more thing, very important thing, is that if here the direction of current is here, in this form, this is the direction of current, then there will be production of current, and that direction would be in this form, opposite. Very important. Okay. Induced current. Here is induced current. This is current due to battery. This is induced ID. Okay. So we will talk why this is opposite to this. We will talk it later when we do Lenz's law. Just remember, if it is running in this direction, the induced EMF will produce current here, and that current will be opposite direction to this. Okay. So that is later part. Now number 2, what we do is keep the key as it is. Now we leave this. After inserting the key, we don't do anything. Let us leave it. Okay, leave it. Okay, just insert it forever. Then what will happen is that here, this is number 2, this is number 1. Okay, the pointer get back to its 0. It means that there will be no more deflection. What does this mean? If it was deflected like this, now if I keep this pressing, then it will come back to the 0. We know that galvanometer is like this. Okay, so if it deflects like this, and if I keep it pressing, then it will come back to 0. That is no deflection. Isn't it? As same as this. If I keep it like this, there was no deflection. Why? Because whenever I kept it as it is, there was no change in the magnetic flux, and it was not moving. Deflection was not there. Here also, whenever I insert it and leave it forever, then what will happen is this magnetic field will remain as it is, and there will be no deflection. But at the first time whenever I just insert it, then it starts the current, it starts the magnetic field, and suddenly it will find the flux, and suddenly it will deflect. And if I keep it pressing, then this magnetic field will remain as it is, and there will be no deflection. Now why this magnetic field do not change? Here we had used bar magnet and we moved and we stopped it, but we have not used here bar magnet. But the main thing is that, very important point, we have used a DC current. If it is 2 ampere, then in 1 second it will become 2 ampere, in another 5 seconds 2 ampere, 1 minute 2 ampere, 4 minutes, 1 hour, the current here will remain 1 ampere. Therefore the magnetic field will remain unchanged. This will not change, and the flux will not change. If the flux do not change, if d phi by dt is 0, then EMF is 0.